Assalamualaikum warahmatullahi wabarakatuh. My name is Muaz bin Abdul Jamil. 25345 is my ID, and I would like to wish you a very good morning, Dr. Fakizan. So basically, in the test one, the task that we were given is to design a 4-bus system for university, and I put the capacity of 100 MVA because I assume it's a medium-sized university with equipments such as lighting, air-conditioned building, laboratories equipment, and also the residential area. So this is my assumption, and since the distance from the generator to the distributions is near, so I only assume that the nominal voltage to be 11 kV. And these are the 5 variables that we have to find once I fill this one. And from this calculation, we know that we have these 5 variables that we need to find. And this is my line data, basically the reactance as well as the admittance value. So I assume from here, I assume the length and I assume the reactance value per phase, and from there I calculate the impedance or reactance, and then I develop the bus impedance more and more. This is my first iteration. I start and then I do the calculation and I got the mismatch of powers of this much. Basically all the values I got just now is 0 0 0 0, so the mismatch of power is quite similar to the previous values of power injected. And then I develop this matrix and calculate, and I end up with this matrix and the mismatch over here. So I inverse the matrix and multiply, so we get this value. So basically the inverse matrix and multiplication, I use this matrix.research.com, the calculator, because it's 555, it's pretty time consuming to do and we don't have much time. And yeah, this is my first result, V1 and the delta 2 V2 and delta 2 angle. Basically the value is pretty close to what I got in my Powerball. And for the first iteration, because if I solve the solution, it's pretty far away, but if I solve only one iteration in the Powerball, then I got the value very close. And then for the second iteration, I continue the process but with the updated values, and then I got to the mismatch of powers and I developed the matrix, and I end up here. This I have to multiply with this because the formula is V2 over V2, so I have to times by V2 in order to get the real value here. And only then I can subtract. So with this final value, I have to write it first. Okay, so and then for the next question, for these questions I actually neglect the resistance because the value is too small, because usually the resistance in the copper wire is like 5 ohm. And if you ask that, is it okay to neglect that? Yes, it is okay, because we have in power system we always have tolerance value like plus minus 5%, and this is included in there, I believe. And then for question 4, I developed the branch and link. I developed the impedance matrix, actually bus impedance matrix, using the branch and link technique. I follow closely the formula in the summary, and this is what I get. And these values I use to calculate the fault current during the fault at bus 3, and then 1 over Z33, and I got this value of current and time. I calculate the actual value by using this base and multiply by the PU, and I got this 4989.36 of fault. And then the voltages for V3, since I assume that the fault impedance is 0, then the V3 goes to 0, and the V0 is 1 for every since the prefault voltage for every buses is 1. So from the calculation I got this 0.5336 pu, 0.4247 pu, 0.3557 pu. Thank you very much, sir. Have a nice day. Good morning. Assalamu alaikum.